In this video, we're going to be talking about empirical formulas. And an empirical formula gives the simplest whole number ratio of atoms in a compound. And this ratio is a mole ratio as well as a ratio between numbers of atoms. And so I don't know if anybody watches The Flash or has. This is good old Barry Allen from the show The Flash, forensic scientist. And so let's say you found some weird substance on the train tracks or at a crime scene. If you're a forensic scientist and you wanted to try to determine the substance, what you would do is try to determine its empirical formula. And I'm sure there's other things you do, of course, but for this class, we'll say we can use the empirical formula to get basic information about the compound. So you'd weigh out the components of the substance and use different instruments to analyze it and try to get at what the compound was. So it's pretty important. And so the empirical formula, okay, like we said here, it gives the simplest whole number ratio of atoms in a compound. For example, if we had this compound here, right, the empirical formula of this compound would be CH2, okay? So in this case, we're dividing these numbers by 3. Both are divisible by 3. And so the empirical formula, or the simplest or lowest, right, whole number ratio of atoms in a compound is going to be CH2. And this is kind of our building block, as we'll see when we talk about molecular formulas. So all compounds in this example with the general formula CnH2n have the same empirical formula and therefore the same percentage composition. So in other words, all of these guys, so C2H4, right? C3H6, C4H8, etc. Right? These guys all have the same empirical formula, all right, of this CH2 guy, CH2. That's the building blocks. That's the simplest whole number ratio for all of these compounds, okay? So that's just an example of what we mean by empirical formula. It's the simplest whole number ratio of the atoms that make up a compound. All right, so let's just do this example real quick, and then we'll talk more about how we'll calculate empirical formulas given some data on the mass of each type of atom in the compound. Okay, write the empirical formulas for the following compounds. So given what we just talked about of the simplest whole number ratio, why don't you pause the video and try to solve these on your own. Okay, and assuming you did that, you're just going to, again, find the simplest whole number ratio. So in this case, both numbers obviously are divisible by 6. So simplest whole number ratio here is going to be CH. And the next one, both numbers are divisible by 2. Okay, and when we do that, we get C4H9. And I can't divide this number up any further, okay, because then I would not get a whole number, right? Like if I divide up it by 2, I would get C2H, what, 4.5? That sounds right. I don't know why that sounds wrong, but yeah, that sounds right. So that's what we would get there. And that would not be a whole number. So I couldn't divide it by 2. Likewise, I couldn't divide it by 3. I couldn't divide it by 4. So that's the simplest whole number ratio we can get here. Okay. This one, both are divisible by 2. So that's the empirical formula. And finally, this guy, I can't really divide it at all because the oxygen is 1, right? So anything I divide it by will give me some decimal number, not a whole number. So actually, in this case, it already is its empirical formula. Okay. So hopefully that makes sense. You're basically looking at these formulas and dividing both of them, if you can, so that you get the simplest ratio of whole numbers to find the empirical formula. Okay, so how do we find the empirical formula if we're giving some experimental data? Like I said, if we went in the lab and we analyzed a compound, how could we do that? What we're going to do is find the masses of the different elements in a sample of the compound, and it's mostly going to be given to you. Convert the masses into moles of the atoms, okay, of the different elements, and then determine the ratio of the moles of atoms, okay, and then express that ratio as the smallest possible ratio of integers. And then write out the empirical formula using the number for each atom and the integer ratio as the subscript in the formula. Okay, so if it's not clear right now, hopefully it will be clear after we do some examples and after you do the homework. Okay, so here we go. A sample of a pure compound is found to be made up of 1.61 grams of phosphorus, 2.98 grams of fluorine. What is the empirical formula of a compound? Okay, so the first thing we're going to do, remember, we have the masses, check, that's step one. Step two, convert the masses into moles of the atoms. So we're going to do that here. So 1.61 grams of phosphorus, and then I'm going to multiply that by the molar mass of phosphorus off of the periodic table, 30.97 grams phosphorus for every 1 mole of phosphorus, okay? When I do that, I get 0.0520 moles of phosphorus. Then I'm going to do the same thing for fluorine here. 2.98 grams of fluorine times for every 1 mole of fluorine, 19.00 grams of fluorine, 0.157 moles of fluorine, okay? And now the next step is I have to find the ratio here. And this is what you're going to do. You always divide by the smallest number, okay? Always divide by the smallest number, meaning I'm going to do this. To find the ratio, I'm going to do 0.520 moles phosphorus divided by 0.0520 moles of phosphorus, and then 0.157 moles of fluorine divided by 0.0520 moles of phosphorus. Again, this is the smallest number between the two, so you divide everything by that number. So hopefully that makes sense. This, when you put that in your calculator, is going to be 1 phosphorus, I'll just put for now. And this, when you put this in your calculator, gives you approximately 3 fluorine. Okay, that's the ratio, the number is 3. So when I want to write the empirical formula, it's going to be 1 phosphorus and 3 fluorine. Okay, this is the empirical formula. Okay, so that's how you do these problems. So let's do a few more examples together. So if it's not clear, again, hopefully it'll become clear as we continue to do these problems together. So here's another one, okay? It's what is the empirical formula of a compound that analyzes as 79.95% carbon, 9.4% hydrogen, and 10.6% oxygen. Okay, so how are we going to do this problem? Okay, so this is worded a little bit differently, as you could tell. They're giving us percentages here and not masses. But don't worry about it. You're going to do all of the steps exactly the same, okay? You could just assume that you have 100 grams of this substance, if you will. So you can convert all of these substances or all of these percentages to grams, okay? So then we can just do everything like we did before, the same exact steps. All right, so why don't you do that? Assuming you have now 79.95 grams of carbon, 9.4 grams of hydrogen, and 10.65 grams of oxygen, find the empirical formula of the compound. So pause the video, do that, and then we'll do it together. Okay, so same idea as what we did before. So we're going to convert all of these to moles using the molar mass on the periodic table. Okay. So I'm just writing all that out right now. Okay, and then 10.65 grams of oxygen times 1 mole of oxygen, 16.00 grams of oxygen, which equals 0.666 moles of oxygen. Okay, so now from this place, right, similar to before, we're going to divide everything by the smallest number. So divide everything by 0.666. Okay, and when we do that, what I hope you got, the ratios here, this is 10, okay, this is 14, this is 1. So the empirical formula then, when you put all that together, is going to be C10, H14, oh, this is the lowest ratio of whole numbers, okay? So we did it, that's it. All right, so now one more problem where we're gonna see something a little bit different again, so you could probably pretty much have an idea of how you would do all of these problems, okay? Here we go. A compound is found to contain 20% of carbon, 2.2% of hydrogen, and 77.8% of chlorine. Determine the empirical formula of the compound. So again, just assume that all of this is grams, the percentages here, it's by mass, okay? And why don't you do the problem again on your own? Okay, so assuming you paused the video and did that problem, I'm just gonna move right along. 20.0 grams carbon times, for every 12.01 grams carbon, 1 mole carbon, okay? 2.2 grams hydrogen times for every 1 mole of hydrogen. Okay, seeing these problems, I know it might be maybe a little bit boring here, but it's going to help you a lot. The more problems you do, the more problems you see. I think it's going to help you a lot. Chlorine, okay, 35.45 grams chlorine. Okay, so when I put all this in my calculator, I get 1.666 again, pretty much, 2.18, and 2.19-ish. I believe when I plugged in my calculator, it's close to 2.18. Okay, so we divide all these by the smallest number, right? 1.666, 1.666, 1.666. And we're going to see, we're going to run into a problem here. This is 1. This is about 1.31. This is about 1.32, I think. It might be a little bit different than my notes, how I wrote it out here. But that's about what we get. Okay, so how do we round these to the smallest whole numbers? Do we just put them as 1 and 1.3? Well, that wouldn't be the smallest whole number, right? Do we round everything down to 1? Well, that's not really what we want to do here. We can round when it's really close. So when it's like 1.95, 1.98, we can round that up to 2, right? Or if it was like 0.9 something, then we can probably round that up to 1. But this really can't be rounded down to 1, okay? It's the thing we're supposed to do, and what we should do is to get this to the nearest whole number. In this case, we're going to multiply everything by 3. Okay. Okay. And when we do that, okay, what we get, this is equal to 3. This is equal to 4. And this is now equal to 4, roughly. These are whole numbers now. Okay. And I'm just going to check that in my calculator just to make sure that that's the case. So 1.31 times 3. Yep. It's 1.93 is what I have here. So again, like I said, that's close enough to where we can round it now up to 4. And same idea for the next one. So the empirical formula now is C3H4Cl4. This is the empirical formula. So what I would do actually is, like, how did I know to multiply everything by 3? Well, what you could do is actually just multiply everything by 2 and then look at your work and see, okay, can I round this? Is it close enough? Like 0.9 something? Okay, if it's not, it would be like 1, or what it would be, 2.6 something, right? Okay, now I'm going to multiply everything by 3 instead of 2, and that's close enough to round to 4. If that's still not good enough, then multiply everything by the next number, okay? The next whole number. But hopefully that makes sense. There's more problems like this in your homework. So give them a shot, excuse me. And in the next video, we're going to be talking about molecular formulas, and we're going to be using these concepts that we learned here for empirical formulas. So again, if you have any problems, reach out to me. I'd be happy to answer them, and see you in the next video.